So 6.6b is in Bravo. We are on page 546, and I already have up there example 6. And one of the things that you'll notice here that we'll continue to work on is when you have two radical signs, you're going to have to square both sides twice, is what that ends up being. So we did it on example 5. Let's continue on with example 6. So in order to get rid of the radical signs, we first of all have to get, if there's more than one radical sign, we have to get one of them all by itself on one side of the equal sign. So this is the case here. So we're going to square both sides. And the left-hand side is really easy because we just take the square root sign off. That's what squaring it does. And then we're left with this here. So in order to do that, we're going to use FOIL. So we'll have 1 minus the square root of 2x times 1 minus the square root of 2x. So we're going to do the FOIL method. And that is, once you do that, I'm going to assume you remember how to do that. 1 minus 2 square root of 2x plus 2x. Okay, so this term right here is what we got when we did the O and the I. The O and the I, the outside and the inside. And then we added them together, and we got that there. So now what we need to do is, since we have one radical sign here, we have to get rid of everything around it. We need to isolate the radical so that we can keep plugging along there. So in one fell swoop, we're going to subtract 1 from there, subtract 2x from there, and do the same over here. Subtract 1, subtract 2x. So when we subtract the 2x, we're going to get negative x. And when we do 1 minus 1, we get 0. So then we're left with negative 2 square root of 2x. All right, so we have a couple different options here. We could divide both sides by negative 2 and then square both sides. Or we could square both sides at this point. Because we don't have anything added or subtracted to this radical, we can actually square this side and square this side. So negative x times negative x is x squared. And that equals negative 2 squared is 4. And then if we square this here, we just get 2x. Because remember, the radical sign comes off. That's our goal. So now we have x squared equals 8x. So whenever we have an exponent of 2 or greater, we have to get everything on one side of the equal sign and set it equal to 0. Then we can factor out an x. Okay. And once we do that, we can continue on and say that x equals 0. This x has to be equal 0, or x equals 8 for this here. Then we plug these in. And we notice when we plug in 8 into the equation, we get 3 equals negative 3. That's what we get. They're not equal, so we know that one goes away, which allows us to use 0. And when we plug 0 into this original equation up here, it does work. So we know that 8 does not work and 0 does work. Okay, so let's jump up to example 7. Again, we're going to look and notice that we do have one radical isolated here. So let's square that and let's square that. This one's going to be a little trickier to square, but let's just take it as it comes. So that's x plus 1. And then we are going to, in fact, I'm just going to write it out, x plus 2. I got carried away with my link there. minus 1 times that. So we're going to do the FOIL method. We're kind of drag this left hand along with us a little bit. So let's do first this whole thing times this whole thing. So x plus 2. Now let's make that in a radical parentheses squared. Okay, so that's our first. Now we're outside, minus 1 square root of x plus 2. And then we're going to do our inside, minus 1 square root of x plus 2. And then we're going to do our last, plus 1. Okay, so we're going to look at this one. Oops, 1. Give me my 1 back. There we go. So we're going to look at this one here first, and see we've got the radical, we've got the squared on there, so if you remember, that just becomes x plus 2. So that's pretty easy. And these two can add together. So remember, when you add these, negative 1 plus negative 1, you get a negative 2, and the x plus 2's just tag along, and that's a plus 1. Now we continue to combine like terms. X plus 3 minus 2 square root of x plus 2. Then we start subtracting things and get everything the way we need it. So we are going to subtract x, and we have 1 equals 3 minus 2 square root of x plus 2. Okay, now we keep moving along. We're going to subtract 3 here and subtract 3 here. So we have negative 2 equals negative 2 square root of x plus 2. And at this point, I am going to divide both sides by negative 2. Okay, last time I didn't. I just squared everything. But since I have this 2 here, and I'm going to divide, and I'm going to divide here, I'm looking at this and going, oh, well, this is just going to be 1. It doesn't give me a fraction. So that makes it a little bit easier. So if you'll kind of look ahead and notice that, oh, if I divide both sides by 2, then this will go away. It won't be a fraction like on the last one. I could have squared both sides and gone from there, but let's just keep going the way we are. Okay, so square. So 1 equals x plus 2. Subtract 2, and I get x equals a negative 1. Okay, that's all I get. So if I take this negative 1, plug it in way up there, we do find out that it works, and that means we're good to go. Okay, notice that this one's a little different. We have a cubed root here. So to get rid of a cubed root, what do you think we're gonna do to both sides? We're gonna cube both sides, because remember, the way to get rid of the radical sign is if the index and the exponent are the same, and then that all goes away. So then we have 4x plus 5 equals 27. 4x equals 22. And divide by 4, we get x equals 22 over 4, which reduces to 11 over 2. Okay? Because we raised each of these to an odd power, the answer will always work. It's only when we raise to an even power that we have to go and check, because remember, odd powers, negative 2 times negative 2 gives me a positive 4. 2 times 2 gives me a positive 4. Whereas when we do odd powers, we get negative 8, and even powers, or positive powers, we get 2 to the third, we get positive 8. So we get two different answers here. Whereas over here, we get the same answer. So one of these may work and one of them may not work. But when we do odd powers, we end up with the correct answer, a negative 8 or a positive 8. So we don't have to test it because it always gives us that right answer. So anyway, just remember odd powers. When you raise something to the odd power, you know it's going to work. It's the even powers. You have to stick it back in and check. Okay, just lastly on page 548, we have two different equations here that they graphed. One is y equals the square root of x, and the other one is y equals the cubed root of x. So what happens here, let me get the graph on here. What happens if we do an x and a y for this one, no matter what we put in here, so let's say we put 0, gives us 0. Then let's say we put in 4, we get a 2. Put in 4, 6, 16, we get a 4. Oh, we can also put in a 9 and get a 3. So when we graph this guy, we've got 4, 2, 16, 4, 9, 3. Okay, we end up with a graph that looks like that. It never goes into negative territory. We don't see the line coming over here at all because this is negative, and we don't see it go down here because this is negative. So it's only in this first quadrant, because if it was over here, our y would be negative. Here, our x is negative, and here they're both negative. So we can't put a negative number in here. We can't take the square root of negative 9. So that won't work. And no matter what number we put in here, when we take the square root, our y is always positive. So that means x and y are always positive, and they're only positive in this first quadrant. Now, if we look at the second one, with the cubed root, we have it a little bit different. We have an x and a y, and let's say we put in 8. Cubed root of 8 is 2. So that would be a point right there. What if we put in 0? Then we get 0. Let's say we put in negative 8. If we put in negative 8, what number times itself? 3 times gives us negative 8, negative 2. So negative 8, negative 2. Oops, I'm sorry. Wrong one. Negative 8. Nope, that was right. Okay. And let's say I put in 1. Cubed root of 1 is 1. Negative 1. Cubed root of negative 1 is negative 1. So I get this weird graph that looks like this. So notice that my cubed root goes into both of these quadrants. Does not go into this one or this one, but it goes into these two because it's a cubed root. So anyway, as you're plugging away, let's see. Are there any that are asking you to graph? You might run into one that has some graphing. I don't see anything. Okay, so you're probably good to go, but it is good to recognize what's going on here with the graph. So that's it for 6.6.